Hey, it's Calc&Compile, your shortcut to simple math and computing.
A 3 by 3 matrix is given. A equal to 1 2 minus 1 2 2 4 and 1 3 minus 3. We have to find its inverse using elementary transformations. We can write A is equal to identity matrix I multiplied by A like this. Now applying row transformation on R2 as R2 minus 2R1 and R3 as R3 minus R1. We get this. Now interchanging R2 and R3, we get this. Next, using transformation on R1 as R1 minus 2R2 and R3 as R3 plus 2R2. We get this. Now make R3 by 2. We get this, and now applying row transformation on R1 as R1 minus 3R2 and R2 as R2 plus 3R3. We get this equation. Now this equation is of the form I equal to A minus A inverse multiplied by A. So we can write A inverse as 9 minus 3 by 2, 5 minus 5 minus 5, 1, 3 minus 2 half 1. In this question, we have to find all solution for the following system of linear equation using elementary transformation. The system is x plus y plus 2z equal to 0, 3x plus 5y plus z equal to 0, and 2x plus 3y plus z equal to 0. We can write the system as ax plus b, where A is matrix of coefficient, x is matrix of unknowns or variables, and b is matrix of constants. As all elements of B or constant matrix are 0, therefore B is null matrix, then the system is homogeneous. So this is the system. The coefficient matrix A equal to 1 1 2 2 3 1 3 5 1. Applying row transformation on R2 as R2 minus 2R1 and on R3 as R3 minus 3R1, we get A equal to 1 1 2 0 1 minus 3 0 2 minus 5. Now applying row transformation on R3 as R3 minus 2R2, we get A equal to 1 1 2 0 1 minus 3 0 0 1. As all rows of coefficient matrix A are non-zero, that is, at least one element of a row is non-zero, the rank of A is 3. As rank of A equal to 3, which is equal to number of unknowns, the homogeneous system is consistent and has a unique and trivial solution. We can rewrite the system as 1 1 2 0 1 minus 3 0 0 1 multiplied by xyz equal to 0 0 0. From this we can get x plus 2y plus z as equation 1, y minus 3z equal to 0 as equation 2, and z equal to 0 as equation 3. Now substituting value of z from equation 3 into equation 2, we get y equal to 0, and then substituting values of y and z from equation 2 and 3 into equation 1, we get x equal to 0. So the system is homogeneous, consistent, and has a trivial and unique solution. This solution is x, y, z equal to 0, 0, 0. In this question also we have to find solution of the system of linear equation using elementary transformation. But the system is x plus 2y minus 2z equal to 1, 3x plus 2y plus 2z equal to 1, and 5x plus 9y equal to 3. So we can rewrite the system as ax equal to b, where a is matrix of coefficient, x is matrix of unknowns, and b is matrix of constants. As one of the elements of b is non-zero, the system is non-homogeneous. So we can write the system as 1 2 minus 1 3 5 2 5 9 0 multiplied by xyz equal to 1 1 3. So the augmented matrix A, B is 1, 2, minus 1, 1, 3, 5, 2, 1, 5, 9, 0, 3. So applying row transformation on R2 as R2 minus 3R1 on an and on R3 as R3 minus 5R1, we get this. Now applying transformation on R3 as R3 minus R2, we get augmented matrix as 1, 2, minus 1, 1, 0, minus 1, 5, minus 2, and 0, 0, 0, 0. From this equation, we get A or coefficient matrix as 1, 2, minus 1, 0, minus 1, 5, 0, 0, 0, and constant matrix as 1, minus 2, 0. As all elements of the last row in A and augmented matrix are 0, rank of A is 2 and also rank of augmented matrix is also 2. So the number of variables in this system is 3, as rank of augmented matrix equal to rank of coefficient matrix but less than number of unknowns. The non-homogeneous system is consistent, has a non-trivial and infinite solution. So we can rewrite the system as 1, 2, minus 1, 0, minus 1, 5, 0, 0, 0, multiplied by x, y, z equal to 1, minus 2, 0. From this we get x plus 2y minus z equal to 1 as equation 1, minus y plus 5z equal to minus 2 as equation 2. Now let z equal to k, as there are infinite solution, let z equal to k. Now substituting value of z in equation 2, we get y equal to 5k plus 2, and substituting values of y and z from equation 2 and equation 1 into equation 1, we get x equal to minus 9k minus 3. So the system is non-homogeneous, consistent, has a non-trivial and infinite solution, which is x, y, z equal to minus 9k minus 3, 5k plus 2, and k. As k varies, there will be infinite solution.
Thanks for watching. Don't forget to like, share, and subscribe. See you in the next one.